The purpose of this program is to demonstrate bond valuation in Python using the Quanlib libraries. I'm going to walk you through this particular problem and then we're going to run it to show you what it does. We import our libraries, specifically we'll need Quanlib, and from my understanding it works well on the 64-bit machine, but you might have trouble if you're dealing with a 32-bit machine. We're going to use the date-time libraries. We're going to use NumPy, Matplotlib, and Pandas. The last two lines from Pandas plotting is to avoid a particular registry conflict when you use Pandas and Matplot. So that's irrelevant to Quantlib, but it's in here. Now the first thing I do is I create a function called QL_to_datetime. And what I'm doing here is converting dates from the Quantlib format to a Python format of dates. That's a particular problem that using Quantlib is its date convention is a little bit different, and if you want to do things like plotting your data, you're going to have to first convert your dates to Python dates. So that's what that particular function does. We'll use it in a moment. Now the first thing we do is get user inputs on the bonds in terms of the maturity date and then the issue date. What we're doing is asking the user to type some values in, and we specify how we want it done: month, day, year. And then what we do is we take it and we split it on the basis of that slash mark, and that's what that input list is for. And then what we're doing is we're stripping that list to the three parts. We're putting first part into a variable called mm, then md, and then my. So in other words, numbers has three values in it, and position 0 is the month, position 1 is the day, position 2, which is the third position, is in the year. We do the same thing for the issue date. So we have a maturity date and an issue date. Then we ask the user for the coupon rate and the yield. And with the coupon rate and yield, it is possible that a user might misunderstand and put a whole number in, say 5 instead of 5%. So we always check for that as well. Then we come down to very Quantlib specific information. If you've ever done bond valuation, say in Excel, what you'll find is, say, the price function in Excel needs things like the dates and conventions and so forth. This is not a lot different than that. This actually has more bells and whistles than Excel because it allows you to do a lot more in terms of bond valuation than Excel does. So what we've got here is we've got the specification on day counters, the calendar, and we're assembling the issue date and maturity date information from above into dates that will be used in Quantlib. We're specifying the tenor, business convention, so forth. Then what we're doing is coming down here and calculating the bond value as of now. So we take today's date, put it into calc date, and then we use that calc date. It's going into the calculation. We're going to take the yield, put it in the calculation, so forth. Now this bond valuation, we're using flat rate all the way through the life of the bond. You can input term structure of interest into this and have it value the bond based on the term structure of interest. We're just using a flat yield curve for this one as an introduction, and you can always get more elaborate by working with the commands that deal with the non-flat term structure. The schedule basically sets out the schedule of the coupons based upon the inputs that you provided. And then we go into the calculation of the fixed rate bond, specifying how we want it done. And these are all Quantlib specific values. And then we pull out the value of the bond. And we're just going to calculate that. That's one of the fixed rate bond elements, so we pull that out. And we're actually going to print that so you can see that as we run it. Then I also put the list of coupon dates in the data frame. And by doing this, what I'm doing is taking the Quantlib dates and put them in here, and we'll convert them to Python dates in a moment. Then what I do is I find out how many coupons there are by looking at that schedule of coupon dates. I create two arrays. One is called clean and one is called D. Clean will be where we store the clean price of the bond, and then D will be where we store the dates. And that -1 means take out the issue date as one of the coupons because it's not a coupon, but it is in the schedule. So I'm taking out the very first date. Then what we're going to do is we're going to loop through all the coupon payment dates. So we're looping through the D array, and we're pulling out the date and then valuing the bond, and then storing it, the value in clean, and then storing the date in D. So we do this for each coupon. So we're calculating the value of the bond for each coupon payments. Then what we have is we have dates, and we're using that function above to convert the dates from Quanlib dates to Python dates. Then we put the dates and the clean price into a data frame, another one, df1, and we're going to specify the date as the index, and then we're going to plot it. And we're plotting, we're going to do a line graph with dots on it. We're going to have a title and labels, standard stuff. So let me go ahead, and we're going to go ahead and run this and just see how to operate this. And it's going to ask us for the date, so we're going to type in the date, say 1/4/2050. Issue date, let's just make one up, 5/4/2000. Coupon rate, again, I'm going to make it up. I'm going to put a whole number. It'll convert it into the decimal that I need in a moment. So I'm going to put 5, and then yield to maturity, I'll put 4. And now it gives you the value of the bond and then the graph. And so the value of the bond is 117.67. And if we look at the graph, we'll see the points and the lines in here as well. Key things to watch out for. This is only good the way it's set up here for a bond where it's been issued and it has yet to mature. So in other words, today's date is somewhere in that range of those two dates that the user provides. But this program could be easily modified to, say, calculate the value of the bond for different yields. It could be modified to get the dirty price. It could be modified to give you daily valuation. So there are a lot of things that you can do with this that are very useful. It's much more flexible than something that you might find in Excel. And it actually will be much more sophisticated type of modeling.